Let's have a look at photo flash systems. Got this here, Elinchrom, I guess that's how you say it. 3000 micro AS, Swiss made studio flash system. And it's quite big and heavy. On the rating plate on the bottom there, it says Elinchrom SA CH1020 Renesis. So apparently it's 100 or 120 volts, 60 hertz, 1760 VA. Weirdly, the serial number is only 310. So this thing, someone was selling a whole bunch of these on separate listings on eBay as unknown condition, and I bought one, and it kind of works mostly. So this is a thing for studio photography, or where you need a lot of light in a flash form for taking photos, or I don't know, other things you might want to flash for. This is one of the more fancy models that allows you to configure the power level quite selectively, as well as the ratio of firing the flash heads. So when I got this thing, I didn't have any flash heads that went on it, but I had a few other flash systems made by other manufacturers, so I created myself some adapters which connect onto these. I worked out and 3D printed a housing for this that fits these connectors, and it allows the outputs to be adapted to other flash systems, even though it says there that you're not supposed to do that. So I found this one really cheap on eBay. Hensel. This one actually come with the right connector, but the pinout's different because it's a different brand. So that one I could just rewire, and then that works fine. And then I've got a bunch of Dynalite heads, so they can connect on either that one or that one. And then Belcar, like this one here, connects on, works. That seems to be okay. I didn't check any sort of compatibility or anything, but just worked out the pinouts, hooked it up, and away it goes. But recently, we're not going to take apart this thing because I've got some others to take apart, and those ones we'll take a look at soon. But they came with, I haven't tried them yet, some of the official Elinchrom flash heads, so we might as well give them a bit of a blast with this. So there's the business end of that. So it's got the modeling lamp. This is a halogen bulb in the center there, and then the flash tube around it, xenon flash tube. So that modeling lamp, it's for telling you, well, it gives you an indication of what the light distribution is going to be like when you fire the flash, so that you can see and set up reflectors and other bits of equipment, get them positioned right, and get a reasonable idea of what it's going to look like before you commit that to film. So on here there's controls, so you can have them, I can't remember what the symbols mean. Modeling lamps on and off, proportional, so the brightness of them will follow the power distribution, and then whether they pulse or dim, I think that's so they dim when it's charging, so that you can, so it charges faster, and I think flash when it's ready, so that you get visual indication that it's ready to fire again. Is that a good explanation? I don't know. Anyway, I want to hook up one of these. Well, I've actually got two of them here. I think there's another one somewhere mislocated. I'm going to put it out of the way because I don't really want it blasting at me. So these ones that have the correct cable on it, you see that's an S2000, which means that it is rated for 2 kilojoules, 2000 joules, 2000 watt seconds. It says there that it should not receive more power than indicated, is interesting. I wonder if it can, because what I found when trying to make the adapter for these is that they won't do anything if you just connect a flash head up to it. You need to link a couple of the pins with a resistor value, and the value of that resistor seems to determine the power level that it's allowed to deliver. So in this system, where it's all digitally controlled, you wouldn't be able to put it higher than it's rated at. The problem with these type of flash systems is the capacitors go leaky, and then they just vent, and then it's ruined. So you've got to keep them active. This one here is 110 volts, as we discussed. I haven't plugged it in for quite a while, so I thought we should have a look at this little power meter as we do that and see what happens. So this is supposed to have a reforming function to make the capacitors happy again when you turn it on after not using it for a while, but I think that's the thing that doesn't work in this, because if you turn it on, it will just start beeping some error code after a while. You see it's flashing that to indicate it's doing the reforming. But it's drawing some power. There's lots of fans going on in there. You can't turn on another output unless you plug something into them. I guess if this was plugged in, then we could turn on that output. Yes, some kind of error code that I don't know, in which case you just turn it off, then put it onto slow mode, and you can watch. It's at a pretty low power level, so that's like overall power to be delivered, and then the distribution is shown there in actual like joules. So if you have more than one output active, yeah, it's going to get angry if we try and fire it with this one without having anything attached. Individually controls, and then the total of that makes this go up and down. You can see how that's as low as you can go. It adjusts that, and it beeps to say it's ready, because that's adjusting the voltage on the capacitors. So if you're trying to go down a long way, then it will have to discharge the capacitors, and as you go up it will charge them up again. So in theory we should be able to push this and it'll fire that flash over there. Yeah, it did. It's on the slowest charging. Yeah, it peaked near 400 watts then to recharge, and there's around 230 something. We put on the modeling lamp. Problem is, I think these heads are from a 220 volt system, whereas this is 110, so it's not gonna be very good. Here it is. Fire it, and then you can see the lamp's off, and then it comes back on once it's charged. So you set those flash heads up on light stands around your studio, use umbrellas, reflectors, diffusers, grids, that sort of thing to get to the desired lighting effect, and then you hook the sync cable from your camera up to this, or you use some kind of flash on your camera like pointing up at the ceiling, and you turn on the photo cell, which will then make this thing very sensitive. It's probably seeing the flashing of LED lights, and that will pick up the pulse of light from another flash to trigger this one. There's also, I think there's some kind of data thing where you can remote control. You can set the channel of this and then remote control it over the light, I think. Anyway, that's flash system. that's a fancy one. The ones I got to take apart today are not quite as fancy. If you want to discharge it, you turn it off as soon as you've fired it. Then it'll be in a slightly safer condition for you to take it apart and to disconnect these cables, because very high voltage DC on these pins all of the time with a massive capacitor bank behind them. So it can be incredibly dangerous when you're connecting and disconnecting these. If you're not being careful, you can actually see on that other one that we didn't use that I've already had a go with whoever previously owned it. It's arced away those. Maybe it got pulled out while it was firing, or maybe it accidentally misfired while the connector was being pulled in or taken out, just by the order of what pins connect and disconnect in. Annoyingly, it's got that high temperature type connector, IEC connector, so I had to find one that would fit in there and wire a plug onto it, because I couldn't find any molded on cables with that type of connector. It's not very common. I'm glad that still works. I hadn't used it for ages. Now, this is what we got to take apart today. Slightly smaller and less digitally exciting, I guess. We've got a 1500 Classic, a professional studio flash system 1500. On the rating label on the bottom there says this is a 220 volt one, 50 hertz, 3520 watts. That's crazy, isn't it? The other one we looked at said 1700. This is, yeah, a lot of power. And then we got this one here, which is a rapid. Maybe that means it charges faster, which should indicate a higher rating, but again, this is a 220 volt one, but this says it's only rated 1000 watts. So I don't really understand what's rapid about that. Very weird and confusing. I haven't tried turning these on. I don't know if they work. I don't want to turn them on now because I want to take them apart, and I don't want to do that once it's got capacitors charged up. And because these they've been sitting here unused for years, and don't know how long they've been sitting unused before I got them, it's possible that the capacitors will just let rip if you were to try them out. What was I going to point out? Oh yeah, that has, no, the rapid one was rated 1000 volts, but 1000 watts, but you see it's got one of the higher current type connectors. These ones go to 20 amps. Whereas this one, which said it needed 3 point whatever kilowatts, it's just a standard, I think 10 amp rated, maybe 15 amp rated. It says 10 amp in there. 10 amp rated IEC inlet. That's a very confusing. That seems like a mistake, what's written on the bottom there. Surely it's 1520 watts, not 3520. That's just bizarre. That seems way too much. So these ones don't have any proportional control. They're all just the same amount of power will be delivered on each output. You can just turn them on and off with these nice buttons. Fire the flash. You've got modeling light level there and flash power there, which will just be varying the voltage that the capacitors are charged up to. And similarly, as we saw before, there's the charge speed with push buttons, and presumably that's the function of the modeling lamp, whether it's going to be dimmed, just off, or on. Dimmed as in it will go down when the flash is charging up and then come back to normal brightness once it's ready. I guess, I don't know, some kind of neon or indicator there. Oh, and a beep. You can turn that on and off. Beep? No. Is it? I don't know. It says cell on that one, so that's like that's the remote trigger. Whereas that one, it looks like that's the beeping noise for whether it's ready or not. Weird. It's all a hodgepodge, and it seems to avoid using English, maybe because it's Swiss made, so it needs to suit all kinds of European languages. These are on off there. These ones it uses empty full. Yeah, so the other one, Micro AS3000, the way that it controls the output level is it fires the flash tubes in an order depending on the ratio of power they want. So the one that has the highest power rating will be fired first, and then after a ratioed length of time, it will fire the other ones depending on what power level they will have been set up to. So it's pretty simple really what it's doing. They've just calibrated it so it can read in actual watt seconds. Alright, let's take these things apart. We're going to start by taking a look inside the rapid one because I want to see what the deal is with this high current input connector, but the relatively low power rating of 1000 watts. Unless they missed out a 0 and it's supposed to be 10,000 watts, but I doubt it because that would be crazy. So these things, you get them apart by peeling off this bumper thing. The other one we took a look at just before, that we're not taking apart, I have opened up before. When I got it, it had a fuse blown inside it, not that one. It's interesting they come with packets of replacement fuses that was attached to there. And they're big grunty 16 amp type. Look at the wire in that. It's not even a high rupturing type, so that's going to cause a big explosion if that goes off. Seems like a bit much for that type of small glass fuse carrier. Let's have a look. Yeah, that's the one. 16 amp 250 volt fuse. Seems a bit crazy. And so that's exposed some screws there, and presumably the same thing will happen on the bottom. You can see there are capacitors through that vent. You got to watch out joining old photo flash stuff up to your nice expensive SLR camera, because quite often the sync input that connects to the camera has got a high voltage on it. Maybe not on these ones, because I checked it's something like 12 volts, but the other brands it can be hundreds of volts because it's meant for old film cameras where it's just a small switch that gets pushed by the shutter being released. But now in modern cameras it's connected across some kind of transistor or FET or SCR, and those things do not like being overvoltaged. In which case you can use a remote wireless trigger. Oh, look at that. Look at that thing. That's quite exciting. Look at that. Look at that. All the good stuff. It's got a... Oh, that's funny. A transformer that looks like the glass is escaping from the plastic. Must be like nylon glass fiber, and the glass is coming out. That's a bit dodgy. There's some kind of quite massive diode there, some smaller diodes, and then these which look like triacs, grunty old school triacs. Oh, look at that. There's also a reefer cap in there that looks like it's already let go. Probably just as well we didn't plug this thing in, because it's probably would like to release a lot more smoke. Look, it's all cracked open. So presumably some of these caps are being used for voltage doubling, and the others are for the storage. Let me pull this out and we can have a look. There's some pretty good bussing going on under there. So it's just a common positive and negative wire going to the main terminals. and then a couple of other thin wires which would be for modeling lamp, power to fans in the flash head, and sensing that something's connected, probably on that tiny little wire. I guess we should, just in case, before we get poking around too much, check for voltage on the capacitors. It's very unlikely that there'll be anything remnant there after all this time, but we should check to make sure. No, it says 0.005, so we're good there. Very important. And I think what we should do is take the other one apart so we can see if the layout's different, and then decide if one or the other is more interesting to take apart further. So this is the one that supposedly draws 3,520 watts. Those would be blowing your breaker, tripping your breaker, blowing your fuse, trying to run it. Okay, what exciting things are in this? More or less the same. Sort of. It's a little bit different. Remember that. It's probably... Oh yeah, so there'll be two tracks there. One will be for the modeling lamp, because it's a light dimmer, and that'll be the filter for it. And then the other one will be for controlling the charging of the caps. And yeah, same crusty transformer in there, with fluff growing all over it. I thought those were handles for pulling the boards out. No, I think it's just a spacer to stop it falling out. You've got a PB4. Looks like some kind of triggering. It's got an optocoupler on it. Some resistors. Look at that. Open frame wire wound resistors. Apparently there's 620 volts there, 310 volts. Serious business. Maybe that's to do with triggering. Perhaps those caps charge up and get discharged into the trigger transformers in the flash heads. I don't know. Only speculating, have not traced out any of this stuff. But basically, it's got a capacitor charger in it, charges up to presumably 620 volts. Maybe more. Some of them go to close to 1,000 volts DC. So that is specific to this 220 volt model. Maybe that's to do with charging. Current limiting resistors and a triac to turn the charger on and off. It's possible. Some kind of CT looking thing there. A few turns and a lot of turns. So it's a charger, charges up capacitors, and then it's got a triggering circuit which sends a pulse of current out to the trigger transformers in the flash heads, and then it's a light dimmer, and then there's an input stage which isolates the sync input from the rest of the circuit, which is probably that optocoupler there. Some more good things on here. Oh, look at that, a 555 timer. That's nice to see. And then two optocouplers. This might be related to the charger. You see here the snail symbol for slow, and then that diamond symbol was for medium, and then there was a rabbit symbol for fast. Yeah. So maybe this is a charge controller. Yeah, those might set the lower charging levels. It probably just pulses the triac on and off instead of leaving it on continuously. The reasons why you'd want to slow the charging rate is so that you can run more of these without tripping your breakers or overloading things, because for the few seconds it's charging, it's drawing a heap of current from the AC. Now that wire there, oh no, that comes from the photocell, that's not off the trigger input. I guess they've wired it directly there with that shielded wire because it's a very sensitive circuit and don't want false triggering like what we saw before when testing the other unit. It looks fairly isolated down there, and that's probably I don't know, it's just turned to crust. It'll be a mains transformer, like 220 volts there, and then, well, it's got two outputs, one on the isolated side for powering that up, and then something on this side, probably for that, another 555, and a CA311E. Maybe that's a comparator for measuring stuff. We might forego that. So let's quickly look in the other unit, see are the same boards in it. I think so. Slightly different though. I bought these with the intention of taking them apart for the video, so I'm not going to worry about putting them back together. Those solders unknown condition from a scrapping place for cheap. I thought it might be fun to take a look inside because I didn't really want to destroy my good one. Oh, these boards are a bit more stiffly retained. Same thing there. This one looked different. I've been zoomed in way too far. It's slightly different. It's missing that little transistory doofy, and that cap there's different, and the resistors otherwise seems to be the same. Oh, that's different. It's got an extra little thingy attached onto thingy. Maybe this housing's bent and it's holding them in a lot tighter than it should be. Just needs more persuasion. Man, that's difficult. Is that? I think it's a plastic rail. Yeah, but yeah, that one's super tight. Okay, this board is more or less the same. It's another one that has voltage ratings, and oh look, you also select whether it's 50 or 60 hertz there. Maybe that's to do with the light dimmers. Oh, also the charging, because there's probably some fixed thing to do with firing the tracks at the right timing. So if you had a 60 hertz model running on 50 hertz, then the light dimmer is not going to be quite correct. Assuming they're doing it that way. I don't know. I think that would probably apply more to the microcontroller version, where they'll be using counters in the microcontroller to do the timing of firing the tracks. No microcontrollers in this one. So then the fluffy transformer board, that's a bit different. It's got some extra stuff. The genuine bodge. Does seem to be genuine though. You see there's a little pad there that's got the wire coming off of it. Looks like it's replacing just one resistor. That one there. Weird. Interesting. Okay, a massive stud mount diode. That's really exciting. That's so big. We need to get it out and take a closer look at it. I think we're going to have to open the other side. Oh yeah, look, it does have the filter in it. It's just a much smaller one. Yeah, blown apart reefer cap there. Good old reefers. Always the way with them. They're using nice soft silicone wires for the high voltage stuff. Well, for any of the power cables. I think this will come apart easily. Just noticing there's some rivets there. Otherwise, everything seems to be screwed together. Okay, we'll attack this one and take the other panel off. I think there's the same diode and things going on in there. They've done like proper grounding there. Look at that. So many lock washers and nuts there. There is a standard for how much of that stuff you're supposed to use, but that might be a bit over the top. Just start the process of getting this all ready to come apart. Ah yes, there is another interesting thing. This tiny little limo style connector there, which I think is another sync input. It's on my other one as well. I remember looking into that at some point. I think it's, I don't know, another type of way of triggering it. Can't remember. It's been a few years since I was obsessed with photo flash systems, buying any junk one that I could find to take it apart and see how it works, and then building those dodgy adapters to use whatever flash heads I could find. Wow, look at that. Massive diodes. They've soldered in a lug on the other side of the diode. There's some proper fuses. Look, it's actually got sand in it. 16 amp one, and look, they provide a spare fuse. That's pretty neat. Does that mean they're expecting it's going to blow? Capacitor mains input suppression cap. Wow, that looks pretty crusty. Just going to take this whole thing apart. It gives you a pinout of the triacs there. That circular shape with gate T1 and T2. Okay, bottom panel comes off. Oh, the actual Elinchrom brand caps there. And they're photo flash caps. 360 volts, 3,300 microfarads. So maybe these are fancy film caps used for voltage doubling. Maybe, would they be film? Not necessarily. I think the rest of the housing's all riveted together. How riveting. So that's the mains input there. Spindly little wires compared to the rest of it. So now that can open up. You can see there all kinds of things. So here, main power to the outputs. Everything is just in parallel, isn't it? That might be the neutral, and then yeah, where the modeling lights are on. And there'll be two things with these switches that click on and off. It's very cunning. Very cunning. Just mushing all this stuff around. So probably it's doing a couple of things. It'll be joining the trigger signal up to the outputs, so it only triggers the ones that are turned on. It'll also be joining the modeling lamp up to the outputs, so the lights are only coming on the ones that are enabled. Then it might also be doing something else cunning in order to light the light there. Light the light. You see there's a really thin wire that comes off each one and goes to that. So it's probably getting a return to light the indicator through the flash head, so it's not going to light up if there's nothing connected, or if the, you see, grab one of these flash heads now, put all the junk all over the cable. They have a switch on them, and don't know if that only controls modeling lamp or that controls like the actual flash head on and off, because it might be that switch is in series with this switch here. Well, at least in series with the light, so that you can tell that it's not enabled. That would be the thing, wouldn't it? What? So it's got a nylock. We need something to hold the backside. A nice ring spinner on that. Oh, some goo come out of that. There's something got on my hands. Lovely. It's just some kind of AC suppression cap. Oh, it's actually two caps to ground, so that tab, yeah, X1 470 nan. Okay, and there's other things up here. That is that weird little LEMO connector on the side comes up to there, to this, and then it goes into the rest of the circuit. So many cable ties on this, don't know where to start. I think it's because it's an addition. They've added additional cable ties that only hold down this stuff from this extra circuit. Oh, look at that. It's actually got mains power going onto that little tiny connector. Oh, that's pretty hopeful. Wow. And then it's across the test button. Yeah, so it is an external way of firing the flash and a way of drawing a 220 volt supply off of this thing. I'm guessing to power some kind of remote controlling device. You can see that the board layout there, 50 milliamp fuse. Okay, so they're being pretty careful about that. Massive, oh, it's a capacitive dropper, isn't it? Okay, so the phasor neutral that come in of the mains goes through this 0.22, so 220 nanofarad cap. So that would limit the current a lot. Okay, so that makes it a bit less scary that they're putting like mains voltage onto that tiny little connector there, because it will be severely current limited. Okay, so there must be some external thingy triggering device that you can use on these. Pretty interesting. Let's free this board. Okay, so this main board here, it says it's model 101. I wonder what the one, what is the one in the other one then? We're gonna have to take the back off of it to find out. I'll do that off the view because there's already too much junk all over the bench at the moment. Just so we can see, is it different? Well, different enough to warrant being a different model of board. No, it's also a 101. Alright then. So there must be very similar units. Maybe they just decided to call it something else, just for fun. Yeah, unfortunately, that's riveted, so I don't think we can get those caps out very easily, but I'm also not sure that it really matters, because what is it going to tell us? So these guys are all in parallel. So they're not a voltage doubler. Wow. So what's the rating on these things? Made in West Germany. 1300 microfarads. What's the voltage? 240 volts. AC. Yeah, maybe it's just a single stage voltage doubler using that cap. Guess that... Well, that probably makes sense, wouldn't it? If it's a 220 volt system, and those big diodes there, those other stud ones are probably involved in that. It's a voltage doubling rectifier with all this lot in parallel. We'll make something like 630-ish volts. Is that what it said on there? It said 620. Okay, so yeah, it's just... And then to do the lower power levels, when you adjust that slider down, it will just be using the triacs just to throttle this off, so it doesn't get to such a high voltage before it says, nah, that's enough. You've got enough of that now. And can we get this stuff out? I think so. We have to undo those triacs though. Oh, no, we can't get it out because it's got going through the middle there. Slipping away. Okay, let's open up this a bit so we can try and trace out the circuit a little bit. Not too much, just a little bit. It's also nicely bundled up cables. Someone put a lot of work into assembling this. I'm guessing it was a very expensive system back when it was manufactured too. Should probably look for date codes on those chips. What do you reckon? 80s? 80s? Could be. Wouldn't be newer than 90s, definitely. Yeah, 9014. So that one's don't know about the date codes on those other components. Good Phillips caps, Phillips resistors, all good made in Europe stuff. Yeah, that one there says, well, I don't know, 8948, unless that's a part number. And that one says 9118. I guess it's a mixture of somewhere the end of the 80s and the start of the 90s. That says 90. And this one is 84. Yeah, so somewhere near the start of the 90s. Good stuff. Undo that grounding wire. Oh, yeah, the triacs. That nice frame thing holding these caps. So is this 2 sets in series? And then an extra one, 2 extra ones. Wonder why. Yes, those were 300 and something volts. And then 3 in parallel, another 3 in parallel in series with that. And then 2 extra ones for some reason. I don't know if we can have a go at tracing this out, see if it makes any sense. Presumably these wire colors mean something, like the blue for neutral maybe, the red for the positive DC. Good triacs there. Oh, that goose heatsink paste, I think. Wow, the remnants of it, like the oil out of it. Okay, maybe, no, we can't free this stuff. Anyway, let's, now it's everywhere. Of course it's everywhere, that's what it likes doing. Didn't clean it up before touching everything. Alright, what's going on here? Oh, there's a fuse. Okay, so that'll be the charger fuse. So the phase coming in, this brown wire, off the main switch. We've got neutral coming in to here. Phase and neutral. Neutral. All that. So it includes that blue wire there. Diode connection. Connection into that stuff. Which I think is a charge controller. That is a light dimmer one there. And so that takes, guess that's the feed out to the lights. Yeah, all the way up to here, where the terminals are at the top. So the neutral switched by the look of it. And then that red wire there, that thin one's probably the phase. Back from the modeling light control. Yeah, phase there. Okay, so that's easy. Blue is the track controlled modeling lights. That thin red one there is the phase, just raw phase coming in, which then gets put out to the lights through the switch. Then additionally the phase there goes through this fuse, 16 amp fuse there, and then onto main terminal of the triac, gate of the triac, I think, I don't know, the white one. Yeah, gate says gate. Comes from that control board. PB2 is one of them. This one, oh yeah, the one that had those charging rates on it. It makes sense. The main terminal of the triac, the other side, here, goes straight out to this white wire, which goes to one side of these caps. Other side of the caps comes into here. Ah, where that goes off to this other cap. Okay, so that's like a DC smoothing thing. So there's a diode. So this phase has gone through a cap, and then we've got a diode to neutral. See, that's part of a rectifier type deal. And then there's another diode there, and then it goes out to one side of that, I don't know which side. This guy here. So that's the neutral, and it's on there. Whereas that other one after the diode is on the other side of that by itself. So that's I think another stage of boosting, maybe. Then there's another diode. The other side of that. Okay, and then another diode. Then it goes to the other side of the caps there. There's also a center point. There seems to be a sensing thing or just a tap off into one of those boards. I think it's, I don't know which one that is. Oh yeah, those are the three sensing things that come back in, presumably to there, through those, to control which ones are getting fired. Because I got a bit lost along the way of these diodes and other business, but what's at the end of the diode chain is this big guy, a connection to the capacitor bank, the other side of it, and then this massive semicron diode, and then the other side of that big diode is the output terminals. So you can't backfeed. Why would they have that diode there? What would that be benefiting? It somehow isolates the charging circuit from the photo flash. I think it's something to do with inductive effects of the long cable going out to the flash tube. I have no idea. Does that mean I got something messed up? It's not, it's different. I don't know, I'd have to sit and draw out the circuit. I'll think about that, and while I'm thinking about that, we'll take apart one of the flash heads and have a look in that, and then I'll think about that circuit a bit more and maybe draw a little diagram so we can talk about it. Do we need to look at anything else in here? Alright, we need a nice bit of mess. Let's make some more. I'm not really sure whether I want to destroy this, because I can still use it on my other one. I've got 3 of them though, I suppose it doesn't matter. It's not even the right size. Well, these are Europeans, and they're not going to be JIS, they're going to be like Phillips and Pozzies. Pretty sure they're Pozzies, and I don't have a Pozzie driver lying around. Of course, because electrical work dictates that you need to use a Pozzie. Yeah, but not this size. This annoyingly insulated ones that don't reach down holes. Yeah, that's no good. Oh, these screws are different lengths, that's great. Oh. Okay, that doesn't actually get us access to anything. It's got a fan in it. So, wow. Just thinking if I pull that off. Okay, I guess that happens. Okay, so it's not that hard. Oh, nice fan. Yeah, so this is a 220 volt one, as we discussed. And it looks like it stays that way because, yeah, the shaded pole motor fan is 220 volts. So on my system, which is a 110 volt one, it's not going to be able to run the fan. I wonder if that's a problem. It will only be a problem if you're using the modeling lamp, which also would need to be replaced with a 110 volt version. So inside here, this is a really nice cable. It's got some quite thick cores and then a bunch of thinner ones. And so the 2 thick ones, the red one and a blue one there, they go straight across each end of the flash tube. The electrodes there. And then these thinner cores, double pole switch. Was it lit up? Can't remember. It looks like the type of switch that would have a neon in it. So what's all that about? The fuse over the other side. Seems like the fan is just wired straight down to the big connector through its own cores, and then this fuse here goes to the switch, and the other side of the switch goes up here to the bulb, light bulb. Okay, and then the other side is a white. Is it a white or a grey and a yellow? Oh yes, the yellow one comes from the cable, then this grey one that comes up here goes to here. Oh, and it goes to the other side of the bulb. Okay, so that's only a light switch, it's nothing else. Right then, so this doesn't turn the flash head on and off. It just turns the light bulb on and off. Probably as suggested by that. So then the flash triggering circuit is permanently wired. That white cord there, one side that goes to the blue end of the trigger transformer, which is that thing there, and then the other one is, I don't know what the other one is, because we've covered those two. There are the modeling lamp, so it must be to ground. Well, yeah, because you only have one side to trigger a flash. Yeah, alright, that makes sense then. So the white wire is probably the one that goes through the light bulb part of the switch. That's how these things work, isn't it? There'll be a bit of current flowing through the trigger transformer, and then it'll get interrupted or dumped, a cap will be dumped onto it, and then that will cause a current pulse or a current decay in there, and then that will get stepped up by the transformer coming out of that yellow wire, perhaps. No, that's a common on one side. The brown wire goes up that glass sleeve onto the outer. There's a piece of wire wound around the outside of the flash tube, and that is connected to the high voltage winding of the trigger transformer. And when a sharp change in current flow on the primary of that transformer will induce a very high voltage in the secondary, which will create an electric field on the surface of the glass, ionize the gas, create a conductive path, and then the flash fires, discharging that big bank of caps. So that's how that works. Alright, photo flash. I'm going to put this back together since I don't really need to destroy this at the moment. It just carefully goes back together. Might put the cover over the light bulbs section because it's very dodgy having that just hanging out in the open. So that just kind of bayonet caps on. I've got the reflectors there, just somewhere else. Though also this whole setup was just completely covered in degraded foam. It was disgusting. It was so hard to clean everything up enough that I wanted to touch it. It took wiping and vacuuming and just a whole case thing that these flash heads came in, which was all nicely cut out foam, had all completely turned to mush and coated everything in this really sticky stuff. That was not good. It's probably why it was being got rid of, because nobody wanted to touch it. So it's easier just to throw it out. Alright, so to finish off, I will have a little look at the circuit and see if it makes any sense. It may not, or I will at least show you and someone more clever can work it out. I also realized I forgot to take a photo for the thumbnail before we took all these things apart. So that's kind of annoying. I will have to sort something out. I'm not going to be putting it back together. Maybe the other one, which isn't so far apart yet, can be sort of put back together and make a thumbnail anyway. That's a job for later on. Now we're going to have a look at the main power circuit here. Took a few goes of fiddling around to see what's actually happening here. What is that wire that I missed? Oh, that's a mid-sense, so it's not involved in this discussion. Okay, so phase comes in through a triac to control through these massive film caps that are all wired in parallel. I presume that's part of a voltage doubler, but it's also would be providing some sort of current limiting. And then we have a voltage doubler circuit that involves, hang on a minute, I forgot one of the diodes. Can't forget diodes. The final diode is here. So 4 diodes, 4 diodes, 2 capacitors, these 2 capacitors, and it's some kind of multi-stage voltage doubler. I don't know exactly what that type is called. Ends up with this, which is that series parallel arrangement of photo flash caps there, and 630 volts apparently, possibly. What is it more? Didn't actually look, did we? Maybe 310, 620. Board R24. No, PB3. R24 is a resistor. PB3. So that goes there. And then this 620 volts business is off of that pin, that diode. Okay, so that is the main. That is the main voltage. Oh well, there you go. Alright, so it's 620 volts by the look of it, and it's a voltage doubler circuit, and so that will work on each half cycle of the mains. AC mains incoming. Current is forced this way through that, so those caps will get charged up. Half peak mains back the other way through there, through there. Is that true? Maybe. Well, because we put a charge on there of half the voltage in the other cycle, that gets added to that, so we'll push through here, charge that one up, and then similarly back on the other direction. That's 2 in series, and then that's in series of that. So you end up around 3 times the peak, roughly, depending on various things. The weather, humidity, how the caps are feeling, whether they've dried out yet. So that triac will be modulating this thing on and off, and it will stop once it reaches a voltage that it's happy with, and it will. So do they sense it? Maybe they sense it at the half bus from here, maybe, because that's a bit easier. I'm not sure. There wasn't a final output voltage feedback, don't think, unless it's done through that diode somehow. Although actually no, it doesn't. Those resistors there go and do something. Yeah, one of those goes into that board. So yeah, there you go, there's the charging circuit, and it uses voltage doublers. Capacitor diode voltage doublers. Still don't know why they've got this massive one here, which is at this point pretty much around the output before it goes off to the flash heads. I presume it's something to do with inductance and ringing. Elinchrom SKN240/08. And those ones are International Rectifier 70HF80. Is that 700 volt 80 amp? Possibly. Great. Hope you enjoyed a look at something a little bit different, some photo flash equipment. And yeah, I have got more of it, so we might do more at some point. I don't know, I'm just deciding this on the day these days, but stay tuned for next time and we'll take apart some other thing and have a look inside it.